All right, this will be for logarithm graphs. It says the logarithm function f of x equals log base a of x is the inverse of g of x equals a to the x. So I am going to prove to you that these two functions are inverses. So I'm going to do that on separate paper. So I want to prove that these functions are inverses. Okay, so remember f of x is basically y equals log base a of x, and g of x is also y equals a to the power of x. So let's see, if we take the inverse of this function, what that means is we swap the x and the y and then solve for y. So y becomes x, and that's going to be log base a, and instead of x, it's going to be a y. Now, how can we solve for y? Well, we have log base a right here, so I can make this the exponent on the letter a, and then I have to do the same thing on both sides. So on the right-hand side, this becomes the exponent of the letter a, log base a, of y. All right, and then same thing on the other side. This becomes the exponent of a, so that's going to be a to the power of x. All right, so a to the power of x, and when this base matches this base, these cancel, and you're just left with y. So y equals a to the power of x, and that is exactly what I have right here on the other function. All right, so that is the proof that these functions are inverses. All right, so the graph of f of x, which is this one, is the graph of g of x with the x and y values reversed. So these two functions have the x and y values reversed. And if you want to sketch the graph by hand, you convert the log function to an exponential equation and then graph the exponential equation. All right, so that's exactly what we're going to do. All right, so we want to sketch the graph of the log function right here. Remember, in exponential form, it's basically b to the x. B to the x equals the argument a. And in logarithmic form, log base b of a equals x. All right, so you can convert back and forth between these. What I like to do is just use the cancellation property. All right, so we said in the notes we're going to rewrite the log function as an exponent equation. So that's what I'm going to do. All right, this right here is base 2. So I'm going to make this the exponent on the number 2. And on the other side of the equal sign, that is going to be the exponent on the y. If this base matches this base, they cancel. And we're left with the x. And we're left with 2 to the power of y. All right, so this is basically what we're going to graph. This is the same as the original. All right, it's the same thing, but it's just written in exponential form. All right, so let's see. Before I go to the graph, let's put some points in here. This is a y, by the way. This is not a 4. And remember, for exponential functions, basically, what you do is, for the y, you do -3, -2, -1, 0, and then 1, 2, 3. All right. So instead of plugging in values for x, I'm plugging in values for y because we have the equation written in terms of x. All right, so let's do the easy ones. We're plugging in y. 2 to the 0 is just 1. Plugging in y equals 1. 2 to the first power is just 2. Plugging in y equals 2. 2 squared is going to be 4. And for y equals 3, 2 to the third is going to be 9. All right, and now we just take the reciprocals. We did 2 to the first power. Okay, and now we do 2 to the power of -1. It's just the reciprocal of +1, so that's going to be 1/2. And for -2, it's the reciprocal of +2. It's going to be 1/4. And for +3, the reciprocal is 1/9. All right. So in case you don't see what I did there, I did the positive ones first. I did 2 to the first power. And if you want to do 2 to the -1, that is the same as the reciprocal of 2 to the first power. All right, and we did 2 squared by plugging it in. If you want to do 2 to the -2, that's the same as 1 over 2 to the second power. All right, so it's just going to be the reciprocal each time when you change the plus-minus sign on the exponent. Anyhow, let's go to the graph. All right, I made a little mistake here. 2 to the third is not 9, that's actually an 8. All right, so that's not 9, that's an 8. And that means the reciprocal is 1 over 8. All right, anyhow, everything else is correct. This is the exponent. 2 to the 0 is 1. Yes, everything else is correct. All right, at x equals 1, we have y equals 0. So x equals 1, y equals 0. All right, at x equals 2, y equals 1. X equals 4, y equals 2. And at x equals 8, y equals 3. So x equals 8 would be about right here. Okay, and y equals 3, it's about right there. All right, at x equals 1/2, it's -1. So 1/2 is -1. At 1/4, it's -2. X equals 1/4, that's -2. And x equals 1/8, which is almost 0. That's at -3. All right, so we can see which way the graph is trending. It's basically going like this. All right, and it looks to me that it is going to approach x equals 0, but never reach. All right, so that right there is the graph for x equals 2 to the y. And the original function was, let me see, it was log base 2 of x equals y. All right, so this was the original. And this is the same thing written in exponential form. All right, so the graph applies to both of these functions. We just changed the form. Now, we're going to get into this later, but you cannot take the log of 0 and you cannot take the log of a negative. So just based on the original equation, x has to be greater than 0. Okay, that is your domain. And you can see it worked out that way. The graph is never going to hit x equals 0. It's going to get closer and closer, but never reach. All right, here we have y equals ln of x. We're going to convert this to exponential form. And I like to do it by using the cancellation property. ln of x is the same as log base e. So I'm just going to rewrite that so people are not confused. ln of x is the same thing as log base e of x. So what I'm going to do, since the log is base e, I'm going to make this the exponent on the number e. And then on the other side of the equal sign, the y is going to be the exponent on the number e. So I did the same thing to both sides. So e to the y, nothing you can do there. E and log of e cancel, and you're left with the x. All right, so this is what we're going to graph. E to the y equals x. Just like last time, we're going to plug in the values for y instead of x because we have x equals. All right, by the way, this would have been the same. It would have been the same thing as e to the power of ln of x. That's the same thing. And the e and the ln would have canceled because ln is log base e. We would have been left with x. Anyhow, onto the graph paper. All right, let's do the positives first. E to the power of y, that's going to be e to the 0. And of course, e to the 0 is just 1. E to the power of 1, if you did it on the calculator, it's approximately 2.7. All right, e squared on the calculator, that's 7.4. And e to the third is 20.1. All right, for the other values, just take the reciprocal. So 20.1, if I take the reciprocal, I get 0.05. All right, if I take the reciprocal of e squared, I get 0.14. And if I just take the reciprocal of e, I get 0.37, which is really just 0.4. Because we're not going to be that precise on the graph anyway. Okay, so at y equals 3, which is right here, it's off the charts. It's already at x equals 20. So at y equals 3, that is way out here. At y equals 2, x is 7.4. So at y equals 2, here's 7, there's 0.4 right there. This would be about 7.5. At y equals 1, it's 2.7. Y equals 1, x is 2.7. At y equals 0, x equals 1. Y equals 0, x equals 1. Y is negative 1, that's 0.4 on the x. It's about there. Y is negative 2, it's 0.14. So it's just getting closer and closer to the y-axis. Y equals negative 3, it's almost there at 0. So that is basically it right there. All right, if I just connect these points and keep going. And on this side right here, it's getting closer and closer to the y-axis, but it never reaches. So that is basically it. Makes sense that the graphs are almost the same. This is x equals 2 to the y, and this is x equals e to the y. E is a little bit more than 2. E is approximately 2.718. So that's why the graphs are almost the same. All right, so this was x equals e to the y, and that is the same as ln of x equals y. Okay, and the thing that you are taking the log of, the argument, has to be greater than 0. So x must be greater than 0, and that is exactly what happened right here. X is greater than 0.